Oh, yeah. Yeah. All right. Yesterday, we talked about in our notes the different types of regression models. We had 6 of them up there. And the very last one was titled Logistic. And I said, yeah, it's like a type. We're not going to see it at all today because that is all of tomorrow. And that's what we're talking about today. Logistic curves, if I were to cover up the second half of it, it would look like an exponential curve. But what happens is that exponential curve eventually levels off. So it does not continue exponentially forever. And it represents real life more realistically. Why? Here's a kind of idea of something that would initially be modeled by exponential growth. If we had like a cell or some bacteria in a petri dish, you know from science a lot of times those will just pull in half, right, and double each time. And so this one would split into 2. And those 2 would split into 4. And those 4 would split, and it would just keep splitting every single time until we run out of room in our petri dish, right? At some point, it's going to run out of room to put more bacteria in that petri dish. And so that is your example of logistic growth, is that reality is in time things cannot continue infinitely growing. Things like fish in a tank. They might grow very quickly when you first put them in there, but at some point we're going to run out of room. The height of a tree, yeah, it continues to grow, but trees are not infinitely tall, right? At some point, they reach a maximum height. The number of people in a amusement park, in a country, in a whatever, number of houses in the Elkhorn South School District seems to be growing very quickly right now. At some point, someday, we are going to run out of room to put houses in this district, right? So there is a maximum to most real life growth. And that's what logistic curves model. This is your format for a logistic curve. We need to understand how to write it. Our calculator doesn't do a great job of showing us the formatting. Your formatting is always going to look like a fraction, some constant on top. In the bottom, it will always say 1 plus. There will be a coefficient of e. This number right here will always be a negative. And then the variable, t or x. It does represent over time, which is why t is commonly used in your logistic growth model. A, B, and C are the numbers that are going to change with our different situations. And as we get these from our calculator eventually today, those are the 3 numbers that we would put in there, is A, B, and C. 1, E, and the variable will never change. The fact that this is negative will never change. Okay? So you'll see a lot of consistencies with these. We'll ask kind of the same types of questions on each of these. And just figuring out how to use our calculator to help us answer these, et cetera, is what we're looking at today. So here is an example. What you are going to see throughout the notes today is a lot of these little boxes off to the side. That means that this is a very common type question. What do we look for in that question, and how do we attack finding the answer to that question? But what you might want to add to that is some other words that could mean the same thing. This situation is talking about an infectious disease spreads in a small city with a population of 10,000. After T days, the number of persons infected with the virus is measured by this logistic model. The question is, how many infected people are there initially? Now, think about the English language. Initially means first, to start with, at the beginning. Any of those could be the same question. And they don't have to literally have the word initially in them. It's something indicating at the very beginning, how many did we start with? And that means plug in 0. Now, this next part is going to be a get to know our calculators moment. If you have the ability to type this in as a fraction, I strongly suggest that you do. If you do not have the ability to type this in as a fraction, you need to make sure to group the denominator with a parentheses. So start with a parentheses before you type in the 1. We are right now evaluating this for v of 0, so we're plugging a 0 in for the variable when we get there. Go ahead and check with your table partner with your answer. Be very careful when you're typing in the exponent. That's where a lot of the mistakes happen in this. It is 0.97, negative 0.97. To avoid any confusion, every single number we do today will be rounded to the nearest hundredth. We're just going to kind of keep that consistent theme through everything. I know we're talking people in this one, but round to your nearest hundredth. Okay, now let's make sure that we got the right answer. I'm pretty sure I saw a correct answer. Ellie, on your calculator, can you give that to me, please? Okay, so we're going to take a minute. If you did not get that, can you either get help from your table partner or myself, and I'm going to come around and fix any that does not have an 8.03 on their calculators right now. Good? Okay. All right, now, that one we have to interpret what to plug in. They do not come out usually. Sometimes they might, but they don't usually come out and say, what is it when t equals 0? But sometimes they will just come out and ask you certain numbers. Now let's talk about how to speed things up on our calculator. Because you just typed that one in, this time I want you to evaluate it at 3 days and at 10 days. Most of you can right now hit second, enter, and it will pull down what you just typed in, arrow back over and change the 0 to a 3. Second, enter, arrow back over and change that 3 to a 10. You need to group your denominator. So when you start here, before you type in the 1, put a parenthesis. That's okay. So let's divide. And then you're going to have to also group your exponent. Well, you don't necessarily have to, but.
That's what I got the very first time I plugged it in. Because that's doing
Oh, I
this
forgot my
whole
E.
equation.
I forgot the E.
Okay, so we hit second E raised to the. Do we still need the caret then?
Mm-hmm.
Okay, that's what I was doing wrong then.
There we go. Okay, go ahead and check with your table partner because you guys are grabbing me answers today. I'm not going to grab my calculator. Round to your nearest hundredth. Mackenzie, when you have V of 3, I'll take that. Okay. How about Nick Peterson? Do you have V of 10? I'm pretty sure I've seen those numbers a couple times today. Those look good. And if you're having any trouble getting those on your calculator, let me know as we go on. I'll come around and help you, make sure we got things typed in correctly. So this is just evaluating your logistic curve at a particular x value. Now, there will be other ways that you can go about this. Eventually today we're going to graph it. Now if you had it graphed, you could use that trace function and let your calculator find a couple different values for you like that. Is always an option as well. We didn't have this one graphed yet, so just typing it in is probably just as easy. Okay, how do we type it in and graph it? Go ahead and hit your y equals. I would again suggest typing this as in a fraction. Now here is the number one mistake people are going to do, is that you need to, when you do this, make this a variable. It has to be a variable. You cannot type in a number for t. Not 0, not 10, nothing. It has to be x. The x that's in your calculator. And then we'll talk about your window. So all I need you to do right now is type that into y equals and hit your window button. And we will talk about how do we pick an appropriate window for a logistic curve. Okay? So just get that typed into y equals. Give me a second here to let people get that typed in, and we'll talk about our window. Again, if you can type it in as a fraction, do so. T needs to be a variable, x, in your calculators. Okay, let's go to our window. Think about what each axis is representing when we draw our x and y axis. Your variable is always your x-axis. Well, our variable is t, which is in days. So as we think about our x min in our window and our x max, we would not have less than 0 days. So go ahead and set your x minimum to 0, and that's always going to be true. Your x maximum is probably the number that we will spend a little bit of time guessing and checking when we do this. There is no real way to find the perfect answer for this. However, look at the situation at the top. It's a city with 10,000 people, right? And on the last page, oops, wrong way. Last page here, when we checked at day 10, already 9,200 of those 10,000 were infected. So we're like already almost to all the people, aren't we? And that's only 10 days later. It does not take you very far on the x-axis usually in a logistic curve. Now we're not there, so I would pick something a little bit bigger than 10, but it doesn't look like we're going to have to go far, right? 12, and sometimes I like to give myself breathing room, so like 15, but I wouldn't go much farther than that. And that's where the guess and check comes in. You might go back and say, okay, that maybe was a bad guess, try something else, but I wouldn't go very far, okay? The y values, that is our function. Those are the people infected, right? Well, again, we would not have less than 0 people. So y minimum is going to be 0. And we kind of already talked about this. How many people are in this city? 10,000, right? Now, that means that's where we can max out at. And I want to give myself some breathing room, just like I did here. So go a little bit above 10,000, like 11,000, I don't know. No like right or wrong, just give yourself some breathing room. And I don't want 11,000 tick marks up my y-axis, so I always change my y scale to something appropriate to the fact that I'm going up to 11,000 to like, I don't know, 1,000. Okay, you don't have to change the scale. Go ahead and get that all typed in, graph it, and again, this is going to be we need to walk around and help each other. My graph should look something like this. And if it does not, you're going to call me over. Ooh, time out. Go ahead and look at the top of that and make sure your plot 1 is unhighlighted. That's probably highlighted because what we've been doing recently is all our scatter plots. Those do not go to it. Arrow up. If you just arrow up, so you're in your y equals page, just arrow up to plot and hit enter. We don't want plot highlighted on this. Arrow up to plot and hit enter, because otherwise it's trying to graph both your scatter plot and the equation we just typed in there. You did. Let's just double check. Your window is really way not what my window is. Then once you change it, then just hit graph. It kind of looks like you might have hit like zoom stat or something maybe.
Cool, Dylan. But now that looks...
Once you type in your window, just hit graph.
I'll give you that one.
It's not right.
You don't have your E right here? You have 1,100. I changed it to 1,000. And I think that's going to fix it. Yep. Anyone else? I emailed him. Yep.
How do I get it to show that when it levels out, it's just showing up?
All right, so we're going to change our window to that stuff up there.
What? This sounds like water in a bottle. What? No, this sounds like... Yeah, that's what I'm saying.
you have 0.097? So I'm going to get rid of that 0 and see if that fixes it. We don't want to hit zoom 9. We want to use our window here.
Oh, there you go. I got it.
What did you do?
I don't know. You like had it typed in wrong, so I just
ignores you.
All right.
So every time we do this, we have to turn our plot one off, but when we do everything else, it has to be on.
When you're doing a scatter plot, if you're doing graphing from a table, then you have to turn that back on. Yeah.
Oh, what's that?
Okay, so guys, a great question up here is when do I have the stat plot on and when do I not? That's based on our question. Did you just type something into your y equals? If you type something into your y equals, you probably do not want scatter plot on. If you are trying to graph a scatter plot, that's when you're going to turn your stat plot back on. Today, at the very last example situation, we're going to actually do both. If you're doing the data that's in your table, you actually can have both on. So we'll look at that as well. But yeah, understanding when to have that on and not is, am I graphing a scatter plot or am I not graphing a scatter plot? All right, we are going to shift gears to a different situation here. This one is talking about Watauga High School has 1,200 students. Bob, Carol, Ted, and Alice start a rumor. That would never happen, would it? Spreads logistically according to the model, where R of T is the number of students who have heard the rumor and T is the number of days. So it gives us this model, and it asks us the first question, how many people have heard the rumor by the end of day 3? So again, a good chance for us to make sure that we can get this typed into our calculator correctly. We are starting this example by just evaluating for T of 3, R of 3. Kaylin, when you guys have an answer at your table, I'll take that from you. All right, how we doing? Everyone's getting that on their calculators, 43.14. Okay, so sticking with this situation, this problem right here is the one that takes the most amount of algebra. We will do it 3 times today. This is the first time, and I'm going to walk you through it. The second time, we're going to look at speeding it up a little bit, and the third time, you're going to do it by yourself. Okay? So it says, when will 1,000 people hear the rumor? In this question, what am I putting 1,000 in for? R of T. Okay, so we are going to set this equal to 1,000. You are going to notice that, again, it starts out this very first time that I do this, that it's going to look like a lot of work. We are going to be able to speed this up a lot as we talk about some shortcuts and what's going to happen every single time I do this problem. Okay. First of all, we are solving an exponential equation because my variable is in the exponent. My exponential equation solving says get that by itself and flip to logarithmic, right? It is currently in the bottom of a fraction. And if that ever happens and we want to get something out of the bottom of the fraction, we multiply both sides by the bottom of the fraction. That is step number 1 in this problem, is we will just start by multiplying both sides by the bottom of the fraction. Now, don't work too far ahead of me on this because I'm going to help you speed it up a little bit. Normally at this point I would say distribute. However, knowing where we are going with this, I'm going to tell you don't do that. I want to get rid of the 1,000, but I don't want to distribute it. What's another option? Divide. Okay, now it's looking a lot more cleaned up. Again, my goal is to get this e raised to the exponent. By itself, we have a few outside numbers to get rid of. What should I do first? Subtract 1. Now, after you do that, I want you to hold off on the calculator stuff for just a second. What would be my next step? Divide, right? And this is what I don't want you to type in your calculator. Just leave it. Because it's going to be some super ugly decimal and we would have to round, and I just don't want you to, it's not worth it. Just leave that alone. And again, this time I'm showing every step, and we're going to be able to speed this up. But from here, my exponent is by itself. Flip to what? Logarithmic. And this is going to be a log base e, which will be natural log. So natural log of 0.2 divided by 399. That's when I want you to finally type that in your calculator. You'll hit your natural log button, type that in, hit equals. And then leave it. And what's the last thing we'll do to solve for t? So once you have typed that in and hit enter, the last thing you're going to do is then hit divide by negative 0.9. The natural log of 0.2 divided by 399 should be some ugly negative number. And then we divide by negative 0.9. And it turns out to be, I don't know what it is, 8.44. And it should turn out to be some nice positive, I mean, still an ugly decimal, but a nice, normal seeming positive number. Okay, I told you we were going to be able to speed this up. Guys, it will not take you very many attempts at this to be able to skip several steps as we do this, because the same thing's going to happen every single time, because this is the same setup every single time. So it kind of looks like at the beginning, and it's not what happens, you just showed all the math behind it, but it kind of looks like those two things just flip-flop spots, right? The 1,000 ended up down there, the bottom ended up over here. Well, the bottom's always the same every time. So after that, we end up subtracting 1 and dividing by the number in front. So a lot of people are going to be able to set this up and jump almost all the way to here by the time we've done this a couple times, okay? So understand it will speed up, or even to here, because we know where this is going, right? So you'll be able to kind of go to here, here maybe, and then all the way to our answer. So it will speed up, I promise. It looks ugly, but it's the same steps every time. Questions? Okay. Like I said, that's the first. We'll try it 3 times total today. All right, this one right here. If we have a school that has 1,200 students in it, what would be the max number of people that would hear the rumor? 1,200 students, right? If we have a town that has 10,000 people in it, what's the max number of people that can get infected with a disease? 10,000. Now, I want you to take those two numbers you just said and look at the equations. Look at that equation. Look at the equation we had on the first example. Where do you see those numbers showing up? The top. It is the numerator, and that's why. So when they ask you for the max, it will always be the numerator, 1,200. Now, guys, they rarely use the word max. Let's talk about other words that they will use. The most. What will it, here's the ones that always catch people. What will it approach in the long run? That means the maximum. What will it ever get up to? Okay. What is the limit to its growth? Now, those two phrases always catch people because they don't understand what but they're saying as time gets to the farthest away it can get, in 3 years from now, what's the most it will ever be? Okay. So limit to its growth, approach over time, maximum, biggest, largest, anything that indicates that, numerator. No work to be done. Questions? Okay. This is our last type of question that they will ask you about a logistic model. When will this spread the fastest? When is our rumor spreading the fastest? And that is the balance between people that know that can pass it on and people we have left to pass it on to. And so there's a delicate balance between that, and it happens at exactly half of the total, which would be half of our numerator. So we start this by setting it equal to half. If our numerator is 1200, we set it equal to 600. This is your second attempt at how to solve something like this. So let's try to speed it up a little bit. So first of all, when they ask us when is it spreading the fastest, we start by just setting it equal to half in the numerator. Now, we kind of talked about, so I don't have to necessarily show it, it kind of looks like those two flip-flop spots, doesn't it? I'm going to multiply by this denominator so it ends up over here. I'm going to divide by the 600 so it ends up over here, right? Okay, now let's talk about this number real quick. If I'm taking the numerator and I know I'm dividing it by half, what's that always going to end up being? Always, right? So when it's a spread the fastest, isn't this number always going to end up being 2 because we will always be dividing it by half of the numerator? So again, talking about how we can speed up this process a little bit. So then I would subtract 1, which will always be 1. Divide by that 399, so we are now sitting at e to the negative 0.9t equals 1 over 399. Have I skipped too many steps for anyone? We're all okay with all the numbers I got up there? Okay, flip it to logarithmic, finish out solving. Just be careful that you don't type all of this in at one time or that you appropriately use parentheses. Some people, that ends up inside the logarithm, which would not be good. Okay. Do you guys, Tanner, you guys agree on an answer here? What do we get?
6.65.
All right, 6.65. Any questions? So that's all the types of questions you can be asked about these logistic curves, with obviously some different wording on some of those things, like what is the maximum, what will it approach, all of those different things. But that's it. Those are the questions right there. So moving on to our next type. You don't have to be handed the logistic equation at the beginning. You might be handed data, and this goes back to what we were doing yesterday. You know how to do this part of it. You're going to go type that into your table. Please clear out your y equals. Go to your tables, clear out your data, type those in, and then I will go through how to do a logistic regression. We will in a little bit. We're not going to graph it right now. We're just going to get the equation. Okay. So we might want to spend some time and just use one of mine for just this section. Might be easier. Okay, so we currently have this in our list 1, list 2. Stat. We'll go to stat. And then hit enter. And then to clear those out, you go clear, and then start typing it. Okay. I have this in here as well. So I have my data in there. To go get my logistic regression equation, I'm going to go to my stat, arrow over to calculate, where we were getting our other regression equations. Okay, and I will arrow down until I find the one that actually says logistic. Mine is option B on that list. Hit enter. If your data is not logistic, it would give you an error message at this point. But it gives you this picture right here. Does anyone need me to run through that again? Okay. So the thing I don't love about your calculator giving this to you is the way that they right? This is a little bit hard to see. You should make it look just like we saw on all of our problems leading up to this. So this is what you guys should be seeing on your calculator right now. We know that this is a fraction, and we just have to put the numbers in the right place, and you have to be careful because it's out of order. C, this one down here, is the numerator. So the last one they give you is actually the numerator of that fraction. We're going to round everything that we do in this entire section to the nearest hundredth. So I will do that here as well. 316,440.71 would be our numerator. Then over 1 plus, because it's always 1 plus in our logistic functions here, A is 23.58. And again, guys, everything to the nearest hundredth. E raised to the, and this is where you have to be careful because B is not a negative number, but the function puts a negative on it, right? So negative 0.1, 0. X or T, I could care less what variable you use there as long as you put a variable in there. Questions? Fancy word for model. Write your equation, right? We are going to use that equation. One of the things, and this is one thing you can do to see how accurate your model, your best fit line is to your data, is you actually can graph both the line and the scatter plot. So that's what we're going to do this time. Please hit your y equals. Type in that equation that we just had, the 316,000. Type that into your y1. With a variable at the end, right? And then you're also going to turn your scatter plot back on. For most of you, that means you can just arrow up to plot 1 and hit enter, or go second y equals and turn your stat plot back on. Once you have that done, to see all of it, and this is the nice part about doing the scatter plot and the equation, is we don't have to set our window. Hit zoom 9. But you got to turn your scatter plot back on. You should see something that looks like this. And we're going to pause because this is where people tend to need a little help. So, anyone not getting a picture that looks like that? Can I see what you have here in y equals? So let's go back up here, hit enter, and then hit zoom 9.
Oh, I thought it wasn't supposed to.
Just this time, because we're graphing both. When it asks you to graph both, you do want it highlighted. You hit go to, option 2 for me. Oh, you have an extra exponent. Let's see if that fixes it. I think you're good. Yep. Anyone else? Okay. That's if we want to graph both onto the same picture. Again, understand when you want the scatter plot or not. If they told us the scatter plot, so we turn plot on. If we were just typing in the model, then we would turn that scatter plot off, and we would just type something into y equals. And just be careful that usually you don't want both unless they are trying to work together. It is the equation that goes with the data. All right, moving on. Based on the regression equation, what will the Aurora population approach in the long run?
31,000.
Numerator, right? The numerator. That's another way of asking you what is the maximum. And I told you they were going to try to trick us because there's no work to be done on that problem. So they're going to ask it to us in a whole bunch of different ways. One of those ways, what does it approach in the long run? What is the maximum? So this one would be our numerator. Okay. Last question I'm going to ask you about this particular problem. Based on the regression equation, when will the population of Aurora first exceed 300,000 people? Where does 300,000 go? The y. Okay, I told you this was happening 3 times today, didn't I? This is your 3rd time. Set it equal to 300,000. Should be a lot faster this time around.
I'm gonna do it.
Okay. Setting it equal to 300,000. If we have done this problem 3 times today, do you think you're going to see it a couple times in your quiz? Yeah. So I'm going to go through one more time here. Very first thing I do is I flip-flop what it equals in the denominator, right? Now that's not what's happening algebraically, but that's what it ends up looking like. So I have 23.58 e to the negative 0.1x equals, and then this is going to get divided by the 300,000, right? And I believe that ends up being 1.05. Okay. So at that point, I would pause, subtract 1. If I subtract 1 from 1.05, it's 0.05, right? Divide by the 23.58. And get to this point. I'm going to pause there. Are we all okay with the numbers that I have up there? It kind of didn't show a lot of work. So now I'm going to flip to logarithmic, log base e, which is natural log of 0.05 over 23.58. I'm finally going to type that ugliness into my calculator, right? And once I get that, I'm going to divide by negative 0.1.
Is it 1.05 or 0.05?
Right here. 1.05.
But then 0 is 0.05.
Yeah, first thing I did was subtracted 1.
Oh, okay.
Okay. And then I get an answer so far of, and I don't remember what it is, 61.56. Guys, 61.56 is not your answer. It's almost your answer, but we didn't read the directions or the question. Not years. Look at the label. Years after 1950. So what is 61 years after 1950? 2011. 2011. Questions? Okay. Oh, yes. I'm going to ask during what year, so I would not round. And I would just say, yeah, it's 2000. It'd be 2011.56. So sometime during that year, like June-ish, July-ish maybe.
Wait one sec.
Okay. We are going to look at one last problem. Guys, you are not going to have to do any work, but I want you to read the directions at it. It's on your note sheet right now. This is a problem I want to look at. It says the number of television ads for a certain product affect the percent of people who purchase the product. We've got this table. Use logistic regression. We just learned how to do that. I would type that into my list 1, list 2, go to my logistic regression. Now, let's pretend like we all did that. And we typed it in, we went to our stat plot, and we got this equation. Look how fast that went, right? And then we read the question. It says, use your model, which I did for us, to predict the limit to the percent of people who will purchase the product. What's our answer? 55.86. So, a different way of asking you, what is the maximum? And they will try to trick you so many different ways of asking that. What's the limit to the percent? It's your maximum, and that is the top number in there, 55.86. Any questions? Okay, now, in this, it is mostly calculator work. There are a couple that require you to show work, like the 3 that we did today, right? Most of those require work, at least your setup, if not actually showing work. So I say when necessary. Most times it is not necessary in this section to show work.